Good morning, everyone. We're Team 6, DragonTech, and today we're going to present to you our automatic aerator. My name is Corey Lee. I'm the project manager.
My name is Jorge Acevedo. I'm the documentation lead.
My name is Jared Molinaro, and I'm the drafter.
My name is Gerardo Davila, and I'm lead editor.
About the project, we constructed a robot that uses a GPS module that navigates within a boundary area for the aerator. The aerator drives within the predetermined parameters set for it, and it aerates the soil while it moves along the yard. It will aerate in a zigzag path predefined within the given boundary. The original goals for the project was that the aerator would follow you as you mowed the lawn. We were going to use a beacon attached to the aerator and the lawnmower itself, and we were also thinking of using Bluetooth to talk with the microcomputer. Some of the modifications we did have to do was that we used GPS instead for the path of the aerator, and that we used the phone's hotspot signal to communicate with the microcomputer. These are some of the pictures of the final 3D rendering of our project that we ended up going with. And this is the final build of our project as closely related to our 3D rendering that we did create.
This here is the final schematic. We have everything built together from the 12 power supply going to the buck converters, which go to the opto isolators. The opto isolators have voltage dividers that go to the motor drivers, and the motor drivers to the motors. We also have the Arduino Uno connected to the opto isolators. We have the 5-volt power supply connected to the Jetson, and the Jetson is connected to the GPS. As for the final block diagram, we have the power supply going to the buck converter, which goes to the motor drivers into the DC motors. And that is talking to the opto isolators, which talk to the Arduino microcontroller. And the Arduino microcontroller talks to the Jetson Nano. And then the microcomputer talks to the GPS module, which is a bidirectional wired connection. And all of these are plugged in by the power supply for the microcomputer.
For the final software flow diagram, we simply have very linear connection. It's going to power on, initialize all the systems, scan for GPS location, make sure it has a fix, detect any boundaries. Then it's going to activate the DC motors, and then it will essentially follow within the boundaries, checks to see if it's on course. If it's not, it'll back up and rotate. If it is, it needs to check if it's finished. If not, it will continue the boundaries. And if it is finished, of course, it'll power on. For the software overview for our project, we used the NVIDIA Jetson Nano for controlling the GPS navigation, and we also used an Arduino Uno for motor control. The Jetson Nano speaks to the Arduino and tells it when to turn on the motors. And now we'll present our demonstration. This video took place on the soccer fields at UTSA. So here's a visual of our electrical components of our automatic aerator. To start, we have our Mighty Max 12-volt 9-amp hour battery that supplies the power to the motors and the motor driver. The motor driver communicates to the Arduino Uno and the motors to tell them when to move. Then the opto isolators here are in place between the Arduino and the motor driver to protect both components. We also have our BJT setup here that's there to ensure that the current is high enough to supply to the motors. Then finally, we have the Jetson connected with the Arduino and the GPS module to give the cue to move the motors to the Arduino. Now let's see it in action. Issues that we ran into during the project, we had some component issues as well as team communication issues. We did not have the Jetson supplying enough power on the GPIO pins to power the motors. We also didn't have enough GPS signal. We also had a GPS antenna break on us. Batteries order also took forever to get here. We were limited due to COVID-19, as well as having work schedule conflicts and other school classes.
Lessons we learned as working in this project was time management, creating a schedule and keeping important deadlines in mind during weekly meetings. We also learned how to work as a team, assigning each member a certain job to complete. And we also learned Python 3, a programming language that was used for the Jetson Nano. And we learned how to manage our budget, which our project had an overall cost of $480. For future plans, we intend to add a detecting sensor so it can stop when it's approaching an object. We also want to add an IMU module to help know which direction it's facing in order to make the course of the area more accurate. And we also will adjust the code to have a more precise path by using the GPS and array more efficiently. For contributions, Corey Lee was the project manager and led our team meetings. Jorge Acevedo was the documentation lead. Me, Gerardo Davila, was lead editor of the software and design of the aerator. Jerry Maldonado was also the project lead in the design of the auto aerator. And we want to give a special announcement to Dr. Patrick Benavides. He helped us a lot during this project. This is our automatic aerator poster. And now we'd like to open the floor for any questions you have.